In this lesson, we're going to learn how to multiply polynomials. The key to multiplying polynomials is the distributive property. You're going to be doing this over and over. So, what we have on the screen in this first example is a monomial times a polynomial with 4 terms. So what you need to do is distribute the outer monomial to all 4 terms inside, which means you're going to be making 4 multiplications. So 2x cubed times x cubed will be 2x to the 6th. Keep your base and multiply, or keep your base and add your exponents. Plus 2 times 3 is 6, x to the 5th. 2 times negative 2 will be negative 4, x to the 4th. And the final term, 2x cubed times 5, will be plus 10x cubed. Now, scan what you have and make sure that you have no like terms that can be combined. I do not, so I'm ending up with a polynomial with 14 terms. It has a leading coefficient of 2, and its degree is 6. Now, binomials times binomials. You're just going to be distributing over and over, but there are different tricks that teachers have come up with to help students remember this process. Now, this is only true for a binomial times a binomial. What you need to do is take this first x and multiply it by the 2 terms in the second binomial. Then you'll take negative 4 and multiply that by 2 terms, negative 4 times the 2 terms in the second binomial, which means you're going to have 4 multiplications. Now, one of the acronyms or mnemonic device that teachers use is FOIL. First, outer, inner, last is what FOIL stands for, and it just helps you remember that you're making 4 multiplications. So the product of the first would be x and the 3x. Multiplying those together will give you 3x to the 2nd power. Then I do my outer terms, which would be x times 2, the ones that are furthest from each other, which gives you plus 2x. Then I switch and do the inner term, which would be negative 4 times 3x, which results in negative 12x. And finally, the product of the last 2 terms would be negative 4 times positive 2, which gives you negative 8. So 4 multiplications, and you're just really making sure you do every combination. When you do it in this form, though, a nice thing that happens is frequently the middle 2 terms can be combined. So this results in, we copy the 3x squared minus 10x minus 8 for a final simplified polynomial. It's a trinomial, leading coefficient of 3 and degree 2. Now, there is a second method that can be very helpful. It's using a box. In this one, 3a plus 4, if you put one term across, or both terms across the top, and then a minus 2, put a and minus 2, or negative 2 right here. And then what you're doing is you're multiplying the 3a times a, which gives you 3a squared. Then you take a times 4, would be positive 4a. Then you do the combination of negative 2 times 3a would be negative 6a, and negative 2 times 4 would be negative 8. So again, you can see that you make a total of 4 multiplications, and then what often occurs is on the diagonal you often have like terms. So I write my answer as 3a squared, combine negative 6 plus 4a would be negative 2a, and recopy the minus 8. So you can really choose which method you prefer. They're both just ways of applying the distributive property. All right, so I'm going to use the mnemonic device FOIL again. So the product of the first would be 5a times 2a is 10a squared. The outer product is 5a times negative 6b. That would be negative 30ab. Then I switch and I do my inner product. Inner would be negative 3b times 2a would be negative 6ab. And I put my variables in alphabetical order. And then the product of the last is negative 3 times negative 6 is positive 18. Let me switch here. Positive 18b squared. So again, my two middle terms are like 10a squared minus 36ab plus 18b squared is my simplified trinomial. Now, in example 5, why don't you pause and see if you can get this one on your own. I'm choosing to use the box method again. So I set x plus 1 and 3x minus 2, and it doesn't matter which one goes across the top and which one goes on the side because of the commutative property. Multiply 3x times x is 3x squared, 3x times 1 is 3x, x times negative 2 is negative 2x, and negative 2 times 1 is negative 2. Now again on the diagonal I have a set of like terms, so I write 3x squared plus 1x minus 2. Now, for larger polynomials, again, you're just doing the distributive property, but sometimes it's helpful if you realize how many multiplications you're going to use or make. In this particular one, I'm going to be making 6 multiplications. Now, I always like to take my smaller polynomial, which is the binomial, and I multiply it by everything in the larger polynomial. So I need to take 3b times all 3 terms. That's going to be my first 3 multiplications. And then I'm going to take negative 4 times all 3. So going in order, I do 3b times b squared. So I start over here, multiplying by the b squared gives me 3b cubed. 3b times 6b, b plus 18b squared. 3 times negative 7 is negative 21b. I'm going to switch colors here so you can see that I'm now going to take negative 4 times all 3 for my second 3 multiplications. So negative 4 times b squared is negative 4b squared. I'm lining it up because it's going to help me combine my like terms. I'm lining it up vertically. Negative 4 times positive 6 is negative 24b. And negative 4 times negative 7 is positive 28. Now I do this because I still have to combine my like terms. I've got 6 terms here, and if I line it up vertically and just combine by adding things together, that gives me 3b cubed, nothing's like with that. 18b squared minus 4b squared would be positive 14b squared. Negative 21b minus 24b would be negative 45b, and then just recopy the plus 28. So it simplifies to a polynomial with 4 terms, degree 3, leading coefficient is 3. Example 7, I'm going to illustrate this one again with the box method. So again, box method is good because it can be used with any size polynomials. So since I did a 2 by 3 box that I drew, I'm going to set up the 4x minus 3 over here, and then across the top I'll put the 3 terms, 2x squared, positive 5x, and negative 1. Now I just need to multiply. 2x squared times 4x would be 8x cubed. 4x times 5x is positive 20x squared. 4x times negative 1 is negative 4x. Now I do negative 3 times all 3 of those terms, so that's going to be negative 6x squared minus 15x plus 3. And again, what happens typically is on the diagonals, I have like terms that can be combined. So that's going to give me a final answer of 8x cubed plus 14x squared minus 19x plus 3. 6 multiplications combined to just 4 terms, leading coefficients 8, degree is 3. Now, an application question that you're often asked is related to area of geometric shapes. So it says the dimensions of a rectangle are shown. Write the area as a simplified polynomial. So hopefully you know that the area of a rectangle is equal to length times width. So what we need to do here is multiply x plus 3 times x plus 2 to find my area if I'm writing it as a simplified polynomial. So since it's a binomial times binomial, I'm going to use a mnemonic device FOIL. So product of the first two terms would be x squared. Product of the outer would be 2x. Inner would be 3x. And the last two terms would be plus 6. Gives me x squared plus 5x plus 6. Remember, FOIL is just a fancy way of remembering the distributive property. Now, if they give you units in this problem, you would say that it is like inches squared or feet squared, but it's just telling us to write it as a simplified polynomial, so there you go. Finally, another application problem says you are designing a rectangular skateboard park on a lot that is on the corner of a city block. The park will have a walkway along two sides. The dimensions of the lot and the walkway are shown in the diagram. Write a polynomial that represents the area of the skateboard park. All right, so what I see is this side is 45 feet long, but the park is bordered, has a sidewalk along the edge, which is x feet. So this side of the actual park would be 45 feet minus whatever the width of that sidewalk is. Whereas over here, it was 33, so this is going to be 33 minus x. Once I do that part, the area is simple. I'm going to multiply 33 minus x times 45 minus x. Again, binomial times a binomial means that I need to multiply first, outer, inner, last. So 33 times 45 is 1,485. Outer would be minus 33x, inner would be minus 45x, and last would be plus x squared. Now, I always like to rewrite it so that the leading coefficient is the one with the highest degree. So I have x squared minus 78x plus 1,485 would be the area of that park. Now, what is the area if the walkway is 3 feet wide? Well, all we have to do now is plug in 3 into the problem, or the expression from above. 3 squared is 9. 78 times 3 is 234 plus 1,485. So if I do 9 minus 234, get negative 225 plus 1,485 gives me 1,260 square feet. A way I could also check this is at the beginning it was 45, so if I now know the walkway is 3 feet wide, 45 minus 3 is 42, and the other side would be 33 minus 3 would be 30, and I check 42 times 30, that is 1,260, so I get the same answer. Okay, you should now see how to use the distributive property to multiply polynomials together of any size.